Hi and welcome to the first tutorial of our education systems for those that are trialing Steel Designer Pro. My name is Michael Crawford. I'm your host for today. I'm going to present to you a way of modeling, and hopefully it's different to what you've seen in the past. So I guess the first thing is you need to open up Solidworks. On this front page we can go to the Projects tab, and the very first project that you'll see, which comes with the installation of the package, is Tute 1. And Tute 1 is a project, and Tute 1 main is the subassembly for that project. We can have multiple project zones, and that's what we call them, project zones. They reside underneath the project and they are subassemblies. In this case we've only got one, so we'll proceed with one. So what we want to do is we want to open up the zone, and the default is selected in the configurations. We want fully resolved, and then click the open button. So now we've opened up the subassembly for tutorial 1. Main is the zone. Okay, so we're in the zone assembly now. What we want to do is we want to add in a welded member. This is going to be a subassembly within the zone which contains our workbench. Now it's going to be a welded member, so the whole thing is fully welded. If you've been using Solidworks for quite some time now, or you're new to it, you will be familiar with weldment profiles or weldment structural member. Now we do things a bit differently, and the reason we do things differently is because we aim for large assembly handling. And we aim for that because we get more benefits out of using components rather than a multi-bodied part. If you wanted to know more about that, please contact us and we'll be happy to show you how to manage assemblies over 1 million components. In fact, I've actually done that myself, and I can prove it to you if you need to see it. However, that's not the topic of this presentation. So what I'm going to do is now we're going to start this welded member assembly, and we need to put in a new one, and we're not exactly sure where it is or what it is, so we're just going to put it in at the origin. So if we go into our welded members command manager toolbar, you'll see up in the top left a new button. Click on new, and that property manager page will open. On the left hand side we have library filters. Library filters are used to store all of our library models inside of our library. So if we go to beams and click on beams and go down and select frames, so we've selected the model filter for frames, which will allow us to do our automated filing. We click on the image where it says here, click here to select library item, and we want to select blank and make sure the information over here on the right hand side has been populated. Then click use. We're going to insert it at the origin, and then we hit the green tick to accept those settings. So what you'll notice now is we've got a couple of files that have been added to the zone assembly, and you'll notice that frames has come into the file name, which was our filter. And we also have a driving sketch component, and driving sketch components are where we put all of our sketches, and then we attach our steelwork components to those. What we want to do is we want to open up the welded member. Because we are creating a welded member, this is where we will spend most of our time working on the welded member frame. At the moment we've got one attachment sketch. Okay, now attachment sketches are used to ensure that we have parametric behavior and linkage all the way up and down our tree, so that when we go to insert something into our project from our libraries, it attaches to the attachment sketches and it stretches the item. And this is true parametric behavior, and we make use of it within Solidworks. So now we have ourselves a driving sketch. What we need to do is we need to create 2 more driving sketches, and we also need to place them into the main into the frames driving sketch. And the reason for that is because our table is a 3D shape, and we need to drive that 3D shape when we insert it into a project. So First things first, let's start with the attachment sketch 1 and have a look at what's in that. So if we edit the attachment sketch 1, you'll see it's a sketch line, and it comes from the left hand side at the origin, and it is horizontally related, and it has an ability to be able to stretch in one direction, so it's left free to float. You'll also notice that this is the line, very first line in the sketch segment. When we create attachment sketches, they always have to be the first line in the attachment sketch. If you accidentally delete a line and then put a line in, get out of the sketch and restart again and make sure that it is the first line in your sketch. If you're not sure whether it is the first line in your sketch, if you right mouse click up the top and you go toolbars, there's a tools. Okay, and in the tools, if you click on it, it will bring up the tools toolbar. And if you click on the measure button and pull down, you'll notice here it says line 1. Okay, that's what gives it away. That tells you that that is line 1. Okay, we'll close that off. You can see that we've got a horizontal sketch. How do we know whether or not it is going from left to right? Well, you simply go down to the additional parameters, and you'll notice that the start point is 0, 0. That's obviously the origin, and the right hand point, which is the end point, is not 0, 0, so that's definitely starting from the left hand side. Now we've got our attachment sketch in, we're going to do the same thing for 2 more attachment sketches. So we just exit out of that sketch, go to the top plane, a flyout toolbar will be presented, click sketch, click on the line. What we want to do is we want to start from the origin, and we want to draw a line vertically. See that little yellow vertical line image that's popped up just below the pen? And then click a point anywhere out there. You'll see that it will continue to keep going and adding more. If this happens, just hit escape. We want to save our sketch. Grab the sketch by left finger mouse click and hold it down and drag and reorder it to the top. Everything that we do is driven from the top down in Solidworks. We want to try to avoid going down and then back up to the top, because then that presents a circular reference. If you're not familiar with circular references, they will give you headaches. And Solidworks will tell you whether you have a circular reference in most cases. So what we're going to do now is we're going to rename it. So if you slowly click on it like I did and hold and wait, it will enter into renaming that feature, or that sketch feature. So we've created the second sketch on the top plane. Now what we want to do is we want to create another sketch on the front plane. And each one of these sketches is 1 line per sketch. So now I've just drawn it from the origin upwards. Okay, so this one will drive the height of our workbench. The one over the back will drive the depth of our workbench, and the one across the front will drive our width of the workbench. Save the sketch, get out, do the same thing, drag it up to the top, rename it AS3. Now we've got all these inside of our main assembly for our welded member. What we want to do now is add the same items down into our driving sketch. Because our driving sketch is going to contain all of our driving sketch segments that we're going to attach our steelwork to, so we need to drive everything from the assembly down into the driving sketch. So we open up by clicking on it and going to the component for the driving sketch, and now we have the component open. So the same thing again, top plane, draw a line, wait for that little horizontal yellow thing to show, there it is. Just make sure that it's been added as vertical and rename it. And you'll notice this little arrow, this is in contextual reference, looking up at the welded member assembly, and it's linked to it. Right? If you wanted to, you can right mouse click up the top here, and you'll see if you just click on it, there's these little dynamic reference buttons which will tell you where these items go. I suggest that if you're not familiar with Solidworks, and even me with my experience of over 25 years, I want to make sure that when I'm looking at something I know where it's going. So I'll toggle those on regardless, so they're on all the time. So if I look at this one, you can see now the little links have come up, and it's telling me that this link is out of context in the assembly above. Okay, now on the front plane, moving along, we're going to draw our vertical line and save the sketch and rename it. Okay, now we're going to close off the component for now, and we're going to link these two to these two. So if we edit the sketch that is attachment sketch 2 in the driving sketch component, you can see that they are not linked. So what we want to do is we want to select the sketch, hit your control key, and select the attachment sketch 2 in the assembly, and we make them equal. Now that's added an equal relationship. So that means that if this changes at this level, it's going to change it at that level. And now we save the sketch, and you can see now it's got a reference. And when I highlight over it, because I've turned on reference arrows, it's showing it that that's actually linked. Now if we go to the attachment sketch 3 and edit its sketch, just bring that down if it happens to be too high, and we make these two equal. Now you could have simply just selected the endpoint and related those and made them coincident, but I found that that can be quite unreliable when you're moving things around. Sometimes you just need to move things from one location to the other, and it might mean that you need to swap ends. When you do that, you can end up with a mess. The best thing to do is just make them equal, and I use equal on all of my relationships. So we'll save the sketch, and now they're all linked to the sketches above. Now that we've done that, we want to hide these so that they are not shown. So we select all of them, and all I've done was hit control, and while I did that, took my finger off the control button and then hit the hide button, and then we go save. Now I'm just going to toggle this off so I don't see this anymore. Now we're going to go back down into the driving sketch. This is where we're going to add all of our sketches, and we're going to add all of our planes to set up our table. Now I'm not a big fan of 3D sketches. I prefer to use 2D sketches and lots of them, and the reason for that is because they're easier to modify. I mean, we live in a world of change, and we want to be able to change things rapidly, and I find that if I needed to move a sketch to a different plane, I can do that fairly quickly. And not only that, I get much more structured parametric behavior behind my movements, whereas sometimes 3D sketches can flip, they can be unreliable, and sometimes they're not the best. But we do use them, don't get me wrong. Attachment sketches for connections are 3D sketches in some instances, but it's only a single sketch. Now obviously if you're doing pipe routing, sometimes you have to come up with quite a convoluted process, and you need, for the compound angles, 3D sketches. However, I know you can still use 2D sketches and limit the amount of movement a 3D sketch has. I'm just going to go through the process now of drawing up my driving sketch for a workbench. Please follow along. So first thing we need to do is we need to set the tabletop. Now the tabletop is going to be driven from the top plane to the top point, so we just click those two and control and then S for shortcut. Now I've got my planes here, so I can just put a plane straight on the top. Now if you don't have your S key shortcuts, just hit the S key, there it is there, there's your shortcut by hitting the S key. You can also use the pull down menu and go reference geometry plane. So this is our tabletop. So what I'm going to do is I'm just going to go top of steel, table. Okay, our plate is probably going to sit above that rather than having it set down, and the reason for that is that it's just simpler to be able to do it. Otherwise you've got to compound all your trimming, and you'll see that as I go. So now we've got our tabletop. What we want to do is we want to add in our table steelwork frame for the top. So if we draw a sketch segment, and what we want to do now is we want to look in our top plane. Okay, so if you hit the space bar and look at it on top, we can draw our frame. So what I want to do now is just drag it, draw a sketch segment from the origin down to the end of the endpoint, right? Or you can carry past it, which is what I would suggest, and same with up the end here, and then just go around in an anti-clockwise fashion. You can go in either direction, but make it consistent, because when you're copying sections, you want to know which way they are going. So I've just dragged those in so that I can get access to the sketches below, and I'm going to make them equal, and that one equal. Now the reason I'm doing this and not attaching the sketch segment is because what if I wanted to manipulate this or change it at some stage? I want to make sure it's easier, and to do that you just make them equal relationships. Okay, so now we've added the frame for the top, a shortcut. Right, so this is definitely it, or you can go up into here and click that, and that takes you to the isometric. Okay, so now we're back to the isometric view. I like to name everything. So this is our top of steel, and then we're going to add a couple more planes. If you click on the front plane, by selecting the front plane, we then can draw our column or legs of our table. Okay, so I've just drawn a sketch on the front plane, and I've drawn one leg, and now I'm drawing another one. In this case I have to go from point to point. I don't have much of a choice, but we know that they're limited in the way that they function anyway. Okay, so these are going to be our front legs. So we save that sketch, front legs. And now we want to do is put one on the rear, so we need our rear legs, and to do that we've got a sketch line here, and what we want to do is run a plane over the back. We've used the front plane for the front, so we've been very lucky to grab that plane, but we need to create another plane up the back. So if we select the top plane and select the sketch segment, right, and then hit S key, we can put a plane in. And by default Solidworks will automatically put in a perpendicular plane to the top plane on that sketch segment. Hit your tick, give it a name, we'll call it rear plane. And then on that rear plane, select sketch, select the two front sketch segments, and we're going to convert the entities so that they get pushed to the back. So if anything changes to these, those two will change as well. We're also going to put in a horizontal brace across the back as well. So from there to there, and we'll give this a distance of say 200 across the back. So you would have seen me use the donut, which if you right mouse click and hold the button down and then shift up, you get the dimension. And then I click the endpoint and then the horizontal line. Save the sketch. I like hiding my planes, so I just hide them because they can get annoying, in fact. So now we've got our front legs and our rear legs and our rear horizontal brace. We want to add in some braces down the sides to tie into that. We're very fortunate for the left hand side, we've already got a plane, so if we just on that plane add a sketch, and we want to line it up so that it sits on that point. Now I just drew it from there to there, and you notice that no yellow line came up when I did it. You just click on the horizontal button, that'll give it a horizontal relationship, and now it's fully defined. Save the sketch. Let's name that sketch before, and we'll call it rear legs and brace. This one's our left brace. Now we need to add our right brace. We don't have a plane on this edge, so we're going to do the same thing again. Select the top plane, select the sketch segment with the control key down, and hit the S key and go plane, and then hit the tick. And we want to call this our right brace plane. And then we want to put a sketch on it. Same thing again, from there to there. And this time, no, didn't do it. Hit the horizontal relationship, and that locks it in place, so we're fully defined. Save your sketch. and we'll call this the right brace. I select the sketch and hide them so they're out of my way. Now, I've got all these items in play, but what I don't want to see, because I don't want to attach to them, is my attachment sketches. So all I did there was select each one with the control key down and then hit hide. So now we've got our basic table. Usually tables are longer in width than what they are in depth, so what I'm going to do now is just add another brace across the top. So to do that, I just select the sketch across the top, or you can now select it under the top of steel there, and we're just going to add a sketch segment, and I'm going to use the midpoint and the midpoint, and that puts another section in on our top to stop it from bowing in the middle. Stiffen it. Okay, so now we've got ourselves a driving sketch. We've got something now we can attach all of our steel sections to. So I'm just going to save it and close my driving sketch and go back to the welded member level assembly. So I've just minimized my tree structure for that item, as I no longer need to work with that. What I'm going to do now is I'm going to start the process of adding all of our steel sections. Now I know that there are going to be legs that are going to be identical, and there are going to be pieces that are identical, but we don't always know that when we're modeling. They can change. So the beautiful thing about using consolidation with Steel Designer Pro is that you can put in individual items, and then when you consolidate they come across as one item. And what I mean by that is that each section, when we insert these as components, are going to have a unique identifying file name, which means that each one of them has a component and each one of them has a drawing. I'm going to show you that so that you can see how that works, and then I'll show you the consolidation and how it works, because consolidation is going to group them all even though they are different files. Okay, so we're going to start putting some sections into our project. To do that, we go to the Parts toolbar in the Command Manager and we select Sections. Now usually with our libraries we'll have sections from the library ready to go, but we're going to start from scratch and we're going to add something new to the library so that we can reuse it over and over again. So what I'm going to do is I'm just going to drop a new component in. So if we go New and we go, and where it says select model filter, we select sections, select the image, select blank, make sure the data in the right hand side is in, select the left hand leg, left hand forward leg, and we'll just leave the settings as they are. At the moment we're inserting on a sketch segment, that's the default setting, and we're going to attach to that sketch segment. So if I hit the green tick, that'll insert a new component into the welded member. You'll see that there's nothing in there. Now when I expose it, you'll see that there is an attachment sketch which has already been attached to the selected sketch segment that we were going to attach to. If we open up the section and show the sketch segment, every single sketch segment as far as sections are concerned are drawn on a sketch segment in an attachment sketch from left to right in its extrusion length. That means that if I was to look on it from the front plane, it will always be horizontal, and this is for drawing, so that they'll always be the same angle every time. So when you go to put it in a drawing, that's the angle of that section. It'll always be horizontal. So let's go back and set the isometric view. If you haven't got weldments turned on, you can still go to right mouse click on any of the tabs at the top and go toolbars, and then you'll see weldments, and you can turn that on. Okay, weldments is down here. There's weldments. We're going to add a structural member. Now structural members are weldment profiles just like they are in Solidworks. If you haven't set it up already, and you should do this, it's part of our training onto the right hand side here and our tips and tricks. under the beginner education, there is a file location that you need to set in order to collect our weldment profiles. Now, if you're not from Australia and you're from Canada or Europe or from the US or India or South Africa, where it says Australia, that's where you'll have your own libraries. But the root folder for our library, for our weldment profiles, is C Steel Designer Pro Library. Don't move this, always leave it as it is. Now, weldment profiles and then the actual standard for that country. Okay, in Australia it's AS New Zealand standard that we use. Now, if you've got other weldment profile libraries in here, you're going to have to remove them temporarily while you're testing or trialing the Steel Designer Pro. And the reason for that is because you may get them mixed up. Steel Designer Pro's connections and welded members all use our weldment profiles, and our weldment profiles are configured weldment profiles. You've probably got your own and they're all single weldment profiles. Well, the difference is with a weldment profile that is configured is that you have all of the sections under the same type. So for instance, in Australia we've got a universal beam. Universal beam has all of its sections under that universal beam, so there'll only be one file, and then all the configurations for all those sections will be in that one file. And that's how we've set up Steel Designer Pro. It'll be a bit different to what you've got set up, I would say, and if you leave them in there, weldment profiles from our library or from other libraries may fail because the sketch segments are different in the weldment profile. They may be drawn back to front or not the same way around when they did the sketch for the profile or when the profile was created. And what happens is when you use the weldment profile and in Solidworks as extrusion methods, it gets the faces mixed up, and then when you've got mates to faces, they will break and things will fall apart. So yeah, make sure that you remove your weldment profiles out of here and just leave ours in there. You can always add them back when you finish with our trial, or alternatively, if you're purchasing our software, then you leave it. Okay, so we click OK. What we want to do now is select structural member up in the weldments tab, and we've given you in the library, depending on which country you're from, section sizes that you can choose from for the leg and frame of our workbench. So in this case, I'm just going to make it out of 40 by say 25, 2.5 material, and I'm going to select it and put it on our attachment sketch. If you're using DSTV, and I stress this a lot, don't use mirror profile or rotate angle in the weldment profile. We actually use mates to rotate and move things around using Steel Designer Pro. And the reason for that is because DSTV needs a certain direction or an angle to be able to create the file. Once you've selected the sketch segment and assigned the weldment profile to that sketch segment, hit the green tick. So now we have our section inside. However, there is another setting that we need to set. If you go up into the options or tools, and then there's options down the bottom here, you go to document properties, we go to weldments. We don't want to rename the cut list folders with the description property value, and we don't create derived configurations, so we turn that off as well. Leave the remaining settings as they are. Hit OK. Now if you go up into the cut list, you'll see that it's automatically defaulted to cut list item 2. Now we require cut list item 1 in all of our sections, and with Steel Designer Pro we use one body per part for our sections, and the same with plates. One body per part allows us to be able to capture from the cut list the information associated to this item and have it put into the custom properties. Now this section is just plain blank, it's got no cuts, it's got a centered relationship, so if I was to go and have a look on the side, you'll see that the origin is in the center of it, which is great for a leg. Okay, we go back to isometric, and you'll notice with me I always leave my models at isometric before I leave them. Now what we want to do is we want to add this to a drawing. So if we go open drawing now, there is no drawing. Now if you've got the latest version, you will have a drawing that comes with it. We're just going to go through the process of creating a new drawing. So you go New, select Drawing, click OK. We want to add the section to the drawing. Hit Escape, or hit the tick. Right, and then go Control S, which will take us straight to a save. And because we've only got one component in this drawing, it's going to come up with the same name as the section that we've actually got in our project. And click Save. Now that that's saved, what we want to do next is swap out the sheet template and set this up so that it's something that's conducive to our library. So in our case, we've got CAD Craftsman as our sheet template, so I'm just going to go back to the C drive. And if you go to the Steel Designer Pro tutorials, the Australian tutorial 1 sheet template, and this is a section sheet template, so we're going to use that one, and then click Apply Changes. Now we need to set this up so that our view looks good, so I'm just going to set it up so that we've got our view, and I'm now going to change it so that it uses the last saved. Okay, so make sure that that's right. And then also what we want to do is we want to remove the tangent edges. So I'm just right mouse clicking on the view to get the pull up menu for that to happen. What we also want to do is we want to hide all types behind the drawings. That means any sketch segments that are gone. We select the view, we want to make it hidden, so it shows that there is a hidden side to our square hollow section. And I'm just going to create some views on my drawing sheet. So I'm just going to put some projected views on that way and that way. Now what I want to do is scale it up. I probably would go to 5. You could go less if you wanted to, say 3.5. But we're going to be using this drawing for other components as well. So we want to make sure that we're capturing the drawing's essence in the fact that some of these sections might be larger than what we've got drawn. So I'm putting in some center lines because I like center lines on symmetrical items, and including the end. Okay, if we use the dimension tool, we can size our dimension, size our section, sorry. Oops, got to be careful what you click on here. That rapid dimensioning tool is pretty cool. I don't use it as often as I should. I usually turn it off because it gets in the way. It's up to you and your preference. So now you can see my dimensions are a bit funny. That's okay. We're in America using Imperial. A bit funny is that we're in Australian standard, so really this should be set as a default to be millimeters. So you use the units, and you'll notice that when I click the units down the bottom here where it says IPS, I can edit the document units, click millimeters, and then go custom, and then we change that to kilograms per meter. Okay, you'll also notice that we've got decimal places. Now this is to do with your drafting standard. So what I'm going to do is swap out the drafting standard as well. So if you go up into the options, go to the document properties, and go load external file. Now we've got set up inside of our library drafting standards already. Now we've got one for plates and we've got one for welded member drafting drawings as well. You can use the same one for welded for a weldment for a section as well. So you click open. At the moment I don't have fonts, so I'm just going to select a temporary font and click OK. You'll notice now that my decimal places have gone. I don't need them. I've removed them for clarity, and tolerances for fabrication are usually within 1 to 2 mil anyway. And now I'm just going to add another dimension across the top so that we've got the overall cut length of our section added. So there's the start of our section. So I'm just going to close off that drawing. So now we've gone back to the section, we can close off that section. Okay, so we've got ourselves one leg, and you can see it inside of our frame, welded member assembly, and there's our section for that leg. Now we're going to use the same leg in every location, but in this case I can't imagine them changing. I'm just going to do a simple design, but usually based on my experience is that you will model in your sections and then one of them will change. You might have to hang a hook off something, or so I'll make them all different and then let the consolidation handle the grouping of those items. But in this case, I'm going to use the duplicate part to make them the same. So I'm selecting duplicate, and I've selected the section I want to duplicate. I'm going to leave insert on sketch segments, and I'm going to select the other 3 sketch segments. Now I could create a mirror and then a mirror, or I could create a circular pattern. At the end of the day, depending on your design intent, I typically like to stick all of my sections on sketch segments, and plates can be either patterned or mirrored. So now that I've added that, by hitting the green tick, you'll see that they've all come in. If you hit Control Q, Control S, they're all in and related to our sketch. Now when they get inserted, each item has their attachment sketch, which was in them when we first started, added. Now it doesn't matter what section I open, there is that drawing behind it. So I don't want to see that again. So that drawing is there, okay, on every single one of those items. So when it inserted, it created 1, 2, 3, 4. But they are all the same item because we duplicated. We use duplicate to create a second or third or fourth instance of the same item. Use copy to create a new item. And that's what we're going to do next. So if I go parts, copy, select the section, and we're going to put it on the horizontal brace. Leave the insert at sketch segments and hit the green tick. Okay, so now this is a completely new component. You can see it's section 2. Every other section was 1. Section 2, instance 1. What we want to do now is we want to trim this back. We can use the Steel Designer Pro tools and the trim part. If you select the section, select the face you're going to trim against, and then hit your green tick, that'll trim that component back. Same with this one. Alright, now our section has changed. Because our section was copied from this section to that section, the drawing or the detailed drawing behind it has been copied as well. So we can open the drawing up and have a look at what's happened. Okay, so you can see the length has automatically changed because the reference to that item has been modified to suit the new component that's gone in. And we've had a couple of dimensions drop off. So we'll just add those dimensions back. Save the drawing and get out. So now we've updated that drawing. How quick was that? Alright, that's all we need to do to get there. Fast. Alright, so this item and that item obviously is going to be the same. So we go to Steel Designer Pro Parts, and we go Duplicate, select the section, select the sketch segment. So that's the same section with a second instance. That's what that second in those brackets mean. So there are 2 of them, and there are 4 of those. Okay, now we're going to add another component to the back, and it's going to be a copy because it's got a different length and it's going to stretch differently compared to these 2, because these 2 are going to be parallel and equal, like these 4 are parallel and equal, whereas this one's stretching in the opposite direction. So we need to copy that one again. So I'm going to copy the one that I've already trimmed, and I'm going to attach it to that sketch segment, which is by default set. Hit your green tick. Okay, now you'll notice that the length of this thing seems to be a bit off. Well, why did that happen? That's because these ones still have, when I copied it across, they're cutting trim planes inside of them that we added when we trimmed. So if you go into this section and go into the planes, you can see that there's a plane there. Okay, and what Steel Designer Pro does is it puts a plane in on the face and then trims the section against the plane. You can trim a section straight against the face, but what we found is that when Solidworks rebuilds after a parametric change, the trim extend does not update. Some particular reason in there doesn't allow the process to do its cutting. So we put a plane in context, and that way it all keeps up to date with parametric behavior. So we edit the feature for the plane that is dangling. So you'll see that I've selected this plane here and I've edited it in context. And then when I did that, it took the old plane that or face which it was related to out, and I need to select the new face. By doing that, that automatically updated it. You can see now it's got a little arrow. The other one that is dangling has the question mark. So that's obviously at the other end, and you'll see that the trim plane for that is back there. What we want to do is we want to move it over to this face. So you just edit the feature, select that face, and hit your tick. And you see the section now has adjusted after I've gotten out of editing in context. Alright, while we've done that, let's just check that drawing to make sure that that's good. So I open up the drawing, and you now see that it's off the page. So the design intent for your section needs to be considered before you even go too far. But it doesn't matter. All we do is just change the scale, update the drawing, move some dimensions around, and I'm missing my center lines. I forgot to add those. It's always good to have your drawings finished before you copy them, otherwise you could be duplicating or copying. Actually, it's copying, not duplicating the error like I just did. So it's probably good to show you that if you don't get your drawing right, you're going to duplicate your work, which you would normally do using Solidworks anyway, especially if you've got a multi-body component. Okay, so now we've got the outside columns and the outside braces. Now we need to create the top. Now our top is going to be mitered. So we're going to do a little bit of a trick in this process of the mitering. I'm going to grab the column leg and copy it. And the reason I'm going to grab that and then copy it is because this has no cuts in it first, because we're going to add 45-degree cuts. So I've just done a copy, selected the sketch segment, and then hit my green tick. You'll notice now that when I take a look on the side of this thing, that section is on center. Well, we don't want it on center, we want it center top. Good old Solidworks. It's a weldment profile, which means that we can edit the weldment profile in context. Locate profile and select the top center. Hit your green tick. Now that moves it down to the top center. Now I'm just using standard Solidworks functionality here to model up this or to make that change to that weldment profile. So now that we've got that built, what we want to do is now put some mitered corners in on these items. A nice new feature in Solidworks, I mean it's been around for a while now, is open part in position. We know that that part is in that position anyway, so we're going to add some cuts to the top of it. So I'm just going to go to the top, and you can see that as soon as I go to the top, it then becomes quite hard to work out what the orientation is, because we were going from left to right, but now we're looking on top, switched it around. So what I want to do now is I want to put some mitered cuts on this section. So if we go to the top plane, put a sketch on there, right, and our cuts are going to come from the top to the left, and we're going to make them 45 degrees. And we're going to go to features, extrude cut, and we want to go through all. Okay, make sure that arrow is pointing that way, and we should be good. Same thing with this one, the top plane. Is that the right way? No, it's not, is it? So it's definitely this way that we should be trimming, from that corner to that corner. Do an extruded cut on that face, and you can see the arrow is going the other way, so what we need to do is flip the side we're going to cut and through all. Okay, now we've got two cuts. I've hit the space bar, isometric, and now I'm going to open up the drawing for this item. You can see it's quite long. Okay, we're going to change the scale, and you can see that our sketch, our dimensions for our end has fallen off by the wayside. Let's put these dimensions back on. Now we've got our 45-degree cuts on the top, we can dimension that up. Some use dimensions like I am now. Now if we've got a 2 meter length, we want to make sure we capture that. It's obvious that this has failed, so that's not a 2 meter length because there's radiuses on the ends. It's gone in to the radius. So I'm just adding in the extra dimensions to this section. So that's my 2 meter. I could dimension the top one and go 2 meters on that as well if I wanted to. So we got 40 dimension there. You can add angles to your cuts. Okay. Alright. This dimension in the middle is a reference dimension. If you click on it, you can put dimensions around it. And good old Solidworks bounces its dimensions on you. Alright, so if you wanted to add an angle to this cut, you can add a sketch segment from here to there, which is not the best way to do it, but Solidworks will not allow you to do a dimension on an angle without a sketch. You could dimension from here to here, but that's not your cut dimension, is it? This one from here to here, and then you could just do a calc to work out what your cut dimension is. This is really your cut dimension, so I've dimensioned that instead. Okay, and I usually pull my center lines out so that they don't lap, but it looks like I've got an issue here with my lapping, so I need to delete my dimension and grab it again and pull it out. It's just some of the things that Solidworks has in its drawings that can drive you insane. So now we've put in that angle, and we can do the other side, or we can put typical on that one. I'm just going to, maybe you're not going to fall for this twice, so we'll bring that out further. And add, see how that can get in the road? I don't want that dimension. If it gets in the road, you can turn off rapid dimensioning, so you just turn that off. Okay, so now we've got our angle cuts as well. Now they're references, so you might want to say that, you know, these ones here are references as well, or alternatively the angles could be a reference. It depends on what your detailing strategy is. Okay, so we saved that drawing. Now we've got those items, or that item detailed up, and it's in our library, in our project for us to use. So now we've got the trim cuts, and you can see that this is the way that it should be, regardless of you know, how it goes in. So let's see what happens when we do a duplicate and a copy. So in this case we're going to do the same thing, but what I want to do is show you how consolidation works. If I go parts, copy, and then I can go from there to there and to there and select those three, and I'm going to copy that component and hit my green tick. So all those files that I just added are now unique, right? They are unique. And you'll notice that my mitre has failed, right? So you can see right now my mitre has failed, and that's because the extension had to go past the column rather than be on the center. But there are some nice little things now that I've actually got these miters in place where I can do some quick adjustments. But because I did a copy, I've got to treat each corner separately. Now if I'd have done a duplicate, you'll notice that if I change one, the other one changes as well because it's the same component, right? But in this case, I'm just going to run around and fix all these so that they work. The quickest way to do that is to just edit the component that I'm going to change by in context, expose the tree. You can see my cuts. Okay, so I've done cuts instead of using our miter tool. I could have used our miter tool, however our miter tool is reliant on the fact that there is another piece on the other side for you to be able to miter against. But in this case, I've not done any extensions to this item at all in order for it to work. So what we're going to do is change that. If we go back to our section, sorry, I should get out of that, and we'll do it in the component. It'll be a lot easier then. So on the right plane, I'm going to add an offset, and it can be any length because we're going to relate this to our model at some stage. Okay, so in this case I want to go back the other way, and I know that our section is a 40 mil, so I'm just going to go with 40. Okay, hit the tick. I'm going to use the Solidworks extend feature, so I select the segment, select the plane, and it extends it. Drag this down. You can see my cut has fallen over. Now I should have done this before I did my copies, so we're going to go back and remove the other ones and then come back and add this. Now it's good that we're going through this because now you can see some of the issues I'm having. Now look at this. This is rapid dimension changes. Okay, if I wanted to select the dimension to delete it, I've got to select the arc. I want a top view, and I want a coincident relationship. Now by keeping everything where it is, the only thing that's going to change, or only thing that is changing right now, is my model. The drawing behind it is automatically updating as I go, which is really good. So we go to the right plane and we're going to add an end plane at this end. All right, and we're going to offset that plane 40 mil, which is picked up, and then we're going to select that plane and we want to extend our section to it. Peel it back down again, go and edit the sketch. I can leave my dimension on, but it will fail anyway. You can see here that the dimension hasn't moved. Add my 45, and you'll see I've still got an error in there, and to find that error, it is related to, you can't use that edge because that's the edge I'm trimming. There is a relationship that is gone, so which one is it? Select that one, that one, that one. I'm not seeing any relationship issues. Maybe it's the top plane. Nope. Okay, when this kind of thing happens, you've got to go in and remove all of the relationships. So let's go back to the top plane. We got an angle. Take the coincident away. Oh, select the coincident, delete. Okay. And we relate it to there, so it can't move. And we want it to there. That fixed it. Something in there it didn't like. Okay, so now we've got everything dragged in. If we finish it off, no, that didn't work. Do that again. Isometric view. In the isometric view, open a drawing up and have a look and see what's happened to our drawing. Nothing fell off. All it did was extend out. Excellent. That was the intent. Save the drawing, close off that piece, and now that we've got that piece right where it is, we can now move those pieces back where they need to be. And obviously, just looking at this, it's not 40 mil, it's half of 40 mil. So because I've done that, it means that when I go to my offset plane, which is at either end, and I modify that offset plane to 20, the cut will move with it. Bang, there it goes. And we can do the same thing on this end to 20 mil as well. Now I could relate that plane to this outside face if I wanted to. I just wanted to show you that you can do miters without relating items. Now I'm back to my 3D model. What I'm going to do is, now that I've done that, I should delete these and reinsert them. So our deletion tool will clean out the file if you select the sections, as well as the drawing associated to that item, and remove them from the model, all in one hit. So the next items that do come in should kick off with a second instance, but it'll be section 5 onwards. So now if we go copy, alright, let's have a look at our miters and see if they've worked. Well, that one looks alright. That one looks alright. That one looks alright. Okay, so now we just need to do is a trim under our leg. So if you rotate around, go to the tools, trim part, select the column, select any one of those faces underneath, and that'll trim our leg back. So that means now that all those 4 legs, because they're identical, have changed. The beauty of parametric behavior. Okay, we need to add a brace through the middle here. Because our braces are the same on that leg and that leg, we can also do a duplicate, but I'm just going to do a copy because we might stiffen up these down the track and we might get caught. But they're not the same because this is set down, so it's a different section altogether because of its set down position. And we hit the green tick. Now in the fab shop you might argue that that piece and that piece are exactly the same, but they're not in the model because one's set down and the other two aren't. Now you could adjust your dimensioning so that they are the same and they are set down in all 3. This is just you and your design intent and how you do your projects. So instead of this piece being on center, I could set that down so that it's the same as this one, but then I would have to set that down as well. For fabrication purposes, it's best to make them the same. So I'm going to modify that and set it down, and I'm going to do the same thing with the one up the back. Remember to adjust the planes on the top center section. Okay, so there's our frame. What we need to do now is add some plates, some base plates, a tabletop plate, and some stiffeners around the top top corners. Collapse everything. Now that I've got all my sections, I'm going to add them to a folder. So I just hit my shift key and selected all of those. Now I'm going to add them to a folder and I'm going to call them sections. So what we're going to do now is we're going to create a base plate and we're going to add the tabletop plate and we'll put some gussets in. So we go down to the bottom left hand corner of our column. We're going to add a plate, but we don't have any plates in the library, so we're going to create a new one. So if you go to new, plates, select blank, We're going to insert at a sketch point. So this point here at the end of that line, and hit my tick. So a new plate has now been added. There's nothing in the plate, so we're going to open up the plate, and we're going to remove the attachment sketch because this is just a plate. We're not going to have an attachment sketch. And on the top plane we're going to add a sketch. Now all plates in Steel Designer Pro are drawn on the top plane, and this is for DXF exports. So what we want to do now is we want to draw a rectangle from a center point. Okay. And give our plate for our base its width and length, and now we want to extrude that, and we'll make it out of 6mm plate. And there's our basic plate. We need to create a drawing for it. If there is no drawing, the newer version has a drawing, so there's no drawing, but when you go to insert a new item from our library, it now adds that new item. So we go new drawing, and all you simply do is just open that drawing up. Okay, so I've added the drawing to the view. I'm going to hit Control S to save the drawing, and in goes the drawing into that folder just by clicking Control S. It's the only item in the drawing, and when I save it, it gets the same name as that component, which is the way our Steel Designer Pro works. So now we need to put a view on there. So in this case it's going to be the top view, and I'm just going to add a projected view because you need to know what the thickness is. We're going to under view hide all types so we don't see the axes or anything. We're going to add some dimensions off to the side, and we need to save a thickness, and we need to change the sheet template. So if you right mouse click, properties, browse. In this case we're down into our tutorials, and we're going to use the project sheet template for plates. Okay, and we need to change the drafting standard for the plate. Go up into options, document properties, load from an external file. We go to our library, Australian drafting standards, change the drafting standards. Whoops, selected the wrong one, should be plate. Click OK, and we need to set the units to kilograms per meters cubed, and we need to change the scale of the drawing so that it's nice and big. There we go, and we click save. There's our drawing sheet for our plate done. There's our plate, and our plate is in our model because we inserted it in the model. Now all we need to do now is just trim the section against the plate. Okay, now that we've done that, our plate is in there. Now we can create some patterns and some mirrors here. We'll probably do that because we're going to add some gussets and we want to pick them all up in one. Alternatively, I can use the copy with mates feature within Solidworks, which allows me to copy from one location to the other fairly quickly. But I'm going to add some center lines in our frame so that we can mirror. So I'm opening up the driving sketch and I'm going to add center planes. So while we were modeling away in here, we didn't add any center planes in our driving sketch. So I'm just going to go to the rear plane and the front plane, hit S, and put in a bisecting plane or a mid plane. Hit my tick. So this is going to be the short center line, and I'm just going to call it short because it is the short length. Same thing with the right plane, so we've got our right plane and our right plane. Hit my green tick. This is going to be our long center line. Okay, so we've got our short and our long center lines. Close off the driving sketch, and now we've got that component in there. So now if we go in, we can select the component and select the short centerline plane and go Insert, Mirror Components, green tick, and you can see it highlighted over there. Hit the green tick and we've got the extra plate for our base plate added now. Now if we select both of these plates and select the long center line, we can create a mirror on the opposite side. Now you can see the two plates, hit the tick, there we go, there's all of our base plates added. Next thing, we need to add our gusset plates. Now gussets are usually set up so that they're on the inside of these items, so I'm going to use the mid plane and a sketch associated to that, and I'm going to do a sketch down at the bottom which will change depending on what section size I use. You can create a sketch at this top level here and have it so that you have it offset, but it won't update when you change the section. What I want to do is have it update when we change the section, but you've got to be very careful about which order and how you set this up in order to be able to do this. So what I'm going to do is I'm just going to take a view looking on the front. I'm going to select my front plane, right, of my component, my driving sketch, and I'm going to do an assembly sketch. Actually, I don't want that, I want that one. I don't want a center one. So now we can relate that edge to that edge, and we can relate that edge to that edge. On my rectangle, I'll draw a diagonal line from there to there and trim it. Dimension it up. Okay, so that's the shape of the plate. Save that, give it a name, gusset, or yeah, gusset, not stiffener. I can spell gusset. Alright, so now I've got my internal gusset. Let's put in that plate. Now you might go, let's start from scratch here, but I've already got a plate, so let's use the same plate that we've got and modify it. So I can go Parts, Copy, save my sketch, insert the sketch point. I want my sketch point for my insertion to be mated there, and hit my tick. Now I'm going to relate this in place, mate this in place. So you notice that no attachments were added for some reason. Hit the tick, add a coincident, and now we can rotate this plate now that it's coincident or mated. I want the top plane and the front plane to be parallel, and that'll turn it around the way that I want it. I want the right plane and my vertical line to be mated. Alright, now what I'm going to do is a little trick. I'm going to edit the sketch of the plate, Control A, and delete everything by hitting the delete key. I'm then going to select the chain on the sketch segment, or sketch, closed sketch that I created for my gusset in my assembly, and I'm going to go Convert Entities. Save my sketch, and now my gusset's been added, but it's not mid-plane, so I'm going to make it mid-plane. I'm going to edit the feature, and I'm going to switch it so now it's mid-plane. There we go. There's my gusset. Now I want to add my gusset to the other side, on the other corner. How would you go about doing that? You could duplicate a new one, or you could do a circular pattern. Insert, Component, Circular, select the plate, select the sketch line on that section because it's going to be around that line, change that to 90 degrees, hit my green tick, and now I've got my gusset in the other side of that corner. Might want to do the same thing right around the whole thing again. The beautiful thing is now I've got my two plates and I already had my mirrors, so that if I go up and drag that up in front, because you have to reorder it in order to be able to get to those plates to add them to the mirrors. I'm going to add my new plates, not my section, my plates. Take a look, yep, there they are. And the same with this one, edit that one and add that plate and that plate and that plate and that plate. There we go. So there we've got the top chord all stiffened. We've got one more plate to put on, and I'm going to copy the base plate again. This is our cap plate for the top. If we notice that when we put in this base plate, it had a center relationship to its sketch. What we want to do now is we want to make a corner relationship. So I'm going to use the same plate again, and I'm going to insert it on its sketch point and hit my tick. Now this one's fully mated. I want to open this up, make sure that it is a 6mm thick plate, which is what I want. Delete everything that's in it and draw my plate from the bottom left outwards. Now if I edit my sketch, you'll notice that my plate is only going to go to the center line when I insert it and relate it. So what I'm going to do is I'm going to add two sketch attachments. So I need one that's horizontal, and I'm going to need one, and I'll drag it up, that is vertical. Now these are my attachment sketches, so I'm going to label them as they are. AS, capitals, AS, AS2. And now I'm going to edit my sketch, and I'm going to give it an offset so that we can grow it based on these two sketch segments. So we hit the other top plane. I need to drag it out and drag this out further. And I'm going to give it 20mm clearance all the way around all of these sketch segments. Okay, now that I've done that, save my sketch, put it back into isometric. I always do this, leave them in isometric at the end, fully right in the middle. Hit my X. Now you'll notice the plate has extended out to the full edge, which is where I wanted it to be. Now I'm going to attach my sketch segments, so I edit my attachment sketch 1, Control, select both the attachment sketch segment and my driving sketch and make them equal. Same with the other one. You'll notice now that it's all updated completely to match the length. And congratulations, you've built your first workbench using Steel Designer Pro. Now, you've modeled it. Next thing that we need to do is deal with the drawings. Okay, so the table's ready. Let's do a consolidation. So if you go over to the Steel Designer Pro consolidation tab in the task pane, you'll see that it's turned off. You want to turn it on. So you've got to click it twice to turn it off and then turn it back on. You won't consolidate at the welded member level, so you need to just save it and close it. And that will bring you into the zone. And now the consolidation will automatically pick up that these items have not been consolidated before. Now, looking at the list of all these components that have come in, they've got a new status under their change type. If we select the whole lot and go process it, Steel Designer Pro will consolidate like items and total them. While it's doing that, it's updating the custom properties, it's putting marks in the custom properties so that they are all populated in the data in the custom properties for each item, including plates, sections, plates and sections. So I just hit a Control S, Control Q. Sometimes you have to do this a couple of times because some data needs to be added and then some data needs to be compared. Okay, and you can see the shape's changed and we just hit process. Okay, so now consolidation is complete. What we want to do is we want to have a look at it. And you can see over here on the right hand side in our consolidation pane, everything that has been consolidated that is identical has been added together in this list. and a mark has been assigned to that item. Now, this is not what you would call a project level project. It's a welded member inside a zone assembly. So we've consolidated the zone, and each component now has some data behind it which allows us to detail this up. Because ideally what we want to do is this table is we just want to put it in our library and we want to reuse it over and over again now that it's in our library. Okay, so the next step that going forward is to set it so that it's got some data, and the data is in there when we get it inserted into our projects. However, consolidation is just putting some temporary data, in this particular case, into our weldment profiles, our sections and our plates, so that you've got that and you can add your marks to your details. But what I'm going to do is I'm just going to show you how all this works at a very basic level, at a project level, after we've added this to the library. But before we add it to the library, we're going to make sure everything is detailed. And to do that, we can just go through simply by clicking the top left button and then go to open to make sure that all the drawings are there behind each component and they actually represent what we want detailed. You can see some of the things we didn't update as we detailed them. Some things did automatically. Okay, so I'm just going to go through each drawing, tidy them up a bit. That's the problem with grabbing the center lines and stretching them. They will automatically adjust. Okay, that one's good. Bring him down a bit. That one's lost its dimensions and the center lines. So doing a little bit of a tidy up on some things that probably could have been tidied up before we got to this stage. However, because these things are consolidated and each item is unique, the consolidation process now recognizes that they are the same, so that when I go to open up the drawing, it's the same drawing. This is obviously our cap plate, so we want to make that quite large. Obviously 1 to 10 isn't going to cut it, so 1 to 20. I want a 25. Actually 1 to 20 is probably better, yeah. Alright, we'll delete the dimensions that are on there off it, put some new ones on. Alright, that plate looks good. I'll do a little bit of an adjustment to it, tidy it up centrally. This plate doesn't look good, so we'll tidy him up. Put some dimensions on it. Now whether you like linear dimensions or ordinate dimensions, that's your choice. Oops, wrong one. One thing we forgot to add to that plate was a chamfer in the corner, so let's just finish that off and tidy him up. This is for removing, well, allowing for a weld to be added first and then this plate added. Just minimize that. Save that. You'll notice that all of our dimensions now have jumped. Okay. And there's a nice little thing that Solidworks doesn't offer you up front, so I just right mouse click and go customize, and then I go to commands and look for dimensions, and there's a chamfer dimension. I usually drag it up and sit it in there. That means that we can select the chamfered edge and just nominate it in the drawing. Line those dimensions up. Alright, that's that plate, and that's it. So now we've got to go and update the welded member drawing, so you can click it from here and open it. Okay, so this is obviously a font that Solidworks offers us, and you can see it's very vague. And you can see here that we've got the weight, the estimated mass of what this table would be. It's quite a heavy table. Good workbench, solid one. Okay, that font, if it comes up looking like that, if you right mouse click up the top and you go toolbars, I think it's under line, where are we, line format, that's it. And then you can toggle that on. That makes it nice and dark, gets rid of the colours. Okay, so now we've got our frame inside our welded member. If you wanted to just make sure you've got enough room and you want to add another view, so I just Control C, Control V, just remove that. I'm going to add a 3D view of my model in colour. Alright. I want to make sure that I've got enough room in my model to be able to put my bill of materials, because my bill of materials is going to come down here. So if I go to Documents and I go Update Bill of Materials, I can only do this after I've consolidated, by the way. And this will give me a bit of an idea on how much room I need. It looks like I'm going to have to move my 3D table away, but you've also noticed that it's wrapped the mark. And you can modify this table to help you make it look and feel better, and save it as a template. What I might do is pull that over there, put that under there, and pull this over here. And I might just reduce the scale ever so slightly. Say, have to be a custom scale. By the looks of it, 1:30. Yeah, that'll do. And there's the table over in the right hand side. Now I just need to add some dimensions and some mark numbers to this steelwork frame. There are ways of bringing in sketch segments so that you can attach them. So in our detail view 2, which we've just exposed, we did have a driving sketch, and in that driving sketch we have sketches that we can bring through and dimensions. So we didn't have any dimensions because we used these attachment sketches, and we didn't have any model sketches, but that's no big deal. So what I want to do is grab the top of scale, sketch, select sketch and go convert entities. That brings in the center lines of all the sketches. You can use the sketches in underneath. I am not fussed either way. So that's brought in my center lines. As you can see, they're in. And on the drawing view sheet 1, my driving sketch, I've got my front legs and I have my rear legs. So in this case I'm just going to use my rear legs and brace sketch and convert those. And you can see that it didn't bring it in where I needed it, so let's put it on top because it's a set down item like the rest. And we go center line, and we're just going to add a center line there, and a center line there. Even though we won't be dimensioning to it, I still put center lines in. Okay, and the last but not least, drawing view 3. Obviously the front legs and the rear legs need to do a sketch and convert entities. Come up with a message telling you you can't do that, so that means out of this one we've actually got to add some center lines manually. Once you've done this and you put it in the library, you won't need to do it again. It's done. That's the beauty of this process. Alright, so there's our workbench frame. So let's just add some dimensions. So from center to center, yep, it's a driving sketch. From center to center, that's a driving sketch. And from there to there, oop, missed that one. Actually, I'll go down to the base. fact, I might bring that up. That'll give me to the top of the table. And then I'll add another dimension, my plate thickness. I'll just put top plate. Alright, whoops, bounces. Don't you like how Solidworks does that to you? You don't want it to, but it does. I know you can turn it off too. Okay, it gives a bit of an idea on what we're going to have for our welded member. I'm just going to delete that out of there. You can put dimensions on this one as well, but you'll find that they all relate to one another. In our libraries, I've set it up so that we've got blocks. So let's add blocks. So if we go add file location, if you go to C drive, Steel Designer Pro Library Australian, and then you go blocks, click OK. And now we've got our blocks, and you go to the blocks, and you can see that we've got blocks for all sorts of things in there, some basics. Okay, as a trial, that's where our blocks go. But at the moment, we don't have a block for annotating our items, so I'm just going to put a note in. So if you click on the plate here in this case and add a new annotation, and we go to link, change the current drawing view to component to which the annotation is attached, and then go to description. Right, you can put the description in if you wanted to, or you can go to mark, which is what I typically use. Now mark will refer back to that plate that you saw us go through earlier. Hit your tick. Now I tend to leave everything except that one there, and I will make it so that the annotation has a border around it under an inspection type. Okay, and you can see that it's stuck it off to the right hand side here. We want a tight fit, 5 characters. No, we want to go tight fit. And you can see that it's stuck it off to the side. Isn't that great? So we have to go X, paste. No, it won't let me do that either. That's a bit weird. Inspection. There we go, that's got it. Hit your tick, and there's our mark. Now what you can do is you can add that to the library under our blocks. If you grab it, and I think the trick is to go, we add to library under blocks, and we'll call it mark note. Okay, so now we add that. It's now part of our library so that we can reuse it over and over again. Alright, so while we're at it, we may as well go through and just copy, and you'll see that it's picking up the mark under each custom property, ready for us to do what we need to. Now you can remove the arrow by clicking on the no arrow, right? That makes it a lot easier to show things. Okay, so that's that one done, and you can go around and just add them on everything. So I'm just going to do that right now. Now this is a very large mark. You can change the marks to suit whatever you want. Okay, so this is a very large mark. And it's obviously typical in most of these, so you probably won't need to put marks on all of them. But I do anyway. It saves confusion and everyone knows where everything is. This should take probably, I don't know, 5 minutes once you've added them all. You can see there's a fair few components in this little workbench, and it hasn't taken us long at all. which is what you want, right? Speed. So we'll pull that over to there. I think the marks are too long. We can reduce them so that they say section 1, section 2, if you wanted to. Now this is behind, so I'm just going to put the word behind in there. Capitals. If I could spell, I'd be good at it, but I can't. Alright, and column legs. Let's make it a bit symmetrical. Now, you can use item balloons as well. I prefer annotations at welded member level and item balloons at zone level to call out your welded members. These are parts, and I'm using an annotation for these items. Now, there's obviously some bonuses that come with either one or the other. If you use balloons, you can put quantity next to them so that you only need to call out one item. So I might even turn that around. We're almost there. I'll grab that one. That's pretty much it. We'll just label these plates. Okay, that should be it. That's enough. We'll get the picture. Okay, so we've finished detailing our table. Now our table has been completed. We can now add it to the library. So we just close off the drawing. Make sure that you're in the welded member to add it to the library so it becomes part of the library. Now it's up to you if you want to keep your sketches on or off. We can hide all the sketches. So if you go to Tools, Hide Sketches, hit your green tick and leave the settings as they are. This will just go through and hide all of our sketches so you can't see them. Anything that's in the top level assembly you have to hide manually because it skips that. Okay, well now we've got ourselves our table. We're going to add it to the library. So if you go to Welded Members, Library Manager, you can see Welded Members, and we go to the Library Manager and we'll check our filters. And what we're going to do is we're just going to create a new filter and we're going to call it Table. So if you go Add, Table, TA, click Add. Oh, it looks like we've got TA already used. Tanks. So just go TB. Okay, so TB has been added. Go back to the library and click off and then click back on, and you can see that table should be in the list. There it is right there. Okay, so we've got ourselves a library filter that we can add our library item to. So we're going to click Add. Now with this, you can drag it over to the right hand side and bring your table across and take a snapshot. Zoom in, snapshot, zoom in, snapshot. Okay, so we've got our table. I'll just move it ever so slightly to the left and then snapshot. Okay, so there's the snapshot image that's going to go into the library, so we've got it. We select which standard we're going to attach it to. So in this case, this was modeled in Australia, so I'm going to use an Australian. And in here, you will see the table. And that way we can go 3 attachment sketch driven table. or Workbench. So Workbench, that's what we were modeling, weren't we? And then go add. Alright, so let's go through the process of adding it to the library. Okay, it's been added. We want to see the table in the library. Click off the table, click on the table, and there it is. There's all the data associated to it. Now it's in the library. What does that mean? All the detailed drawings, that table, all of its plates, its legs, its sections, the whole lot is in the library, ready for us to reinsert into any project. So then we'll go back up and we'll turn on projects and turn on the toolbar. Open up the document control center, or sorry, the project control center. Go down into the project and open it up. So we'll just do a rebuild on that. What we want to do now is we want to delete this welded member because we've got it in the library now. Click on the top plate and delete. Now if it says it can't remove it because there's a file locked and we have to remove it manually, that's fine. We just go in and go open. I just did a Control Q, Control S before I open, and then go delete. There we go. Sometimes that happens, and Solidworks has still got some kind of reference or an attachment to the back end that won't let you delete it until you do a Control Q, Control S. Okay, so now what we want to do is we want to put in a whole heap of these tables. So we start off with a driving sketch. So we're going to put in a new driving sketch. Blank one. By default the filter's set to driving sketches, so we don't need to change that. Click use. We're going to insert it at the origin, hit the green tick. Oh, I forgot to convert it to an envelope. There's a setting in there for that as well, but you can do it this way. So if you click on it, go to the component properties and then go envelope and click OK. All of our driving sketches are envelopes. If we open up the driving sketch, let's put in some work in here so that we can add different tables and see how they all function. How's that sound? Alright, so the first thing we want to do is we want to start with plan view layout. So top. Alright, so you're in your office and you've decided that you want to put a new workbench in your workshop, and you've got to do a building layout. So let's do the building layout. So on the top plane, I'm going to draw a sketch rectangle, and in this case I've got say 15 meters across the width of my building, and I've got 3 6-meter bays, so 18 meters for the length of my building. Alright, that's my building frame. Now I might want to go select chain, and I want to offset sketch offset, use 152 girt. And that's my girts. It's just there just to show me that that is my wall. Okay. Save my sketch. That's the building perimeter, so we'll call that building perimeter. Actually, I'll just put P here. That'll be enough. Alright, now I'm going to put in my bench and where I want to put my benches. So in that case, I'm just going to go top. Let's have a look and see how much room I've got. Okay, so my benches have to be transportable. I want to be able to pull them out and relocate them. I want to be able to move them as well, using my jib crane or block and tackle to drag them, whichever way floats your boat. So let's draw in our base. 2 sketch segments for a table. We might make it say 1200. And we want to make it so that we've got say 1200 from there. We might have rack down the side, so let's give us 1200 plus a rack, so 2200. How's that sound? To that location. And then across the back we might want to go, I'm going to have a rack along there as well, so I want to go 2200 there as well. Alright, I want my bench to be 1200 deep, that way I have to go around it, and I want to be able to probably make it 2400 long. Alright, so it's a nice big long bench. Do the same thing again. So I just copy my sketch, Control C, Control V, and I'll put another workbench inside as well. Same location off from the boundary, but this time I want to make it say longer, 3600. Right, probably a bit too long because we don't have a central bar in it, but actually I'll leave it at 24. and I'll make this one 2 meters just to show you that you're going to get variances in them. Alright, so from there to there I'm probably going to need, say, 3 meters because I'm going to be moving material around in between them. So that's my 2 benches. And then what I might do is I might just make a little bench off to the right here with a Control V because I still got it in memory. Line it up with that one. And put 2 benches side by side to make it longer. Alright, and we'll make that one 2 meters as well. Actually, I want to make it 2400. We'll make it 2800 just to show you the difference between them. How's that sound? So there's our 2 benches in the top corner of our office, of our workshop. Okay. Now, I want to add in my height for my legs. So if I go, these are my tables. Now you notice the direction at which I drew these. I drew them from that corner that way and from that corner that way, right? Because that's how my attachment sketches work. So I've got to make them the same, right? And then I go, I'm going to select that sketchman, select the top plane and that sketch segment and put a plane on it perpendicular because I want to be able to set up my heights. Alright, so this bench is going to be the same height as that one. So I'm going to put 2 legs on there. Make them equal. Give them a height. What's good bench height? Meter. Yep. Okay, save my sketch. And that is my 2 rear table. Attachment sketch, height attachment sketches. Table plan attachment sketches. Okay, and 2 rear table height planes. H-E-I-G-H-T. Alright, now we do the same thing on this side. And we want this one to be longer, just to see how it all functions. Alright, so we go 1200 for that one. So that's a bit higher. Alright, so we can go front, table, H-E-I-G-H-T, attachment sketch. And we go front, table, height, plane. And we hide that as well. Alright, there's my table attachment sketches in my main driving sketch in my zone. Okay, so now I've got 2 items on my job. I should zoom extents, which is that one, and just come out a little bit. Now I'm going to bring my tables in from the library and I'm going to do a multiple attached test on my welded member table. So if I click on the welded members and I go to beams or any other shortcut up the top and then select the image for the welded member, in this case the beams come up, you may have a blank empty box. Just click on that box and it will expose the library for welded members. Okay, once it's done that, we go to table, select the table, make sure she's populated over here, click use, and this is going to be a multiple attached model, so you want to toggle that on, and we're going to put this one in first. So this one, and then this one, and that one. So in my image, I haven't drawn them in yet. You can open up the image in the library and you can draw in attachment sketch 1, attachment sketch 2, attachment sketch 3. Right? 1 was that one, 2 was that one, and 3 was the vertical. Alright, let's test it now, see what happens. Hit the green tick. Should copy the model out of the library and size it. I made all the dinging noises. That's related to Solidworks sounds. Right. So my table's turned red for some reason, which means it's not a perfect model. However, that could just mean one of 2 things. It just needs a rebuild at a lower level. So if I open it up, let's have a look. Some of the sections have collapsed. Okay, which ones? Just one in the middle. Alright, what is it that's failed? Oh, it looks like we didn't update the 2 planes when we copied that piece over. Okay, that's the reason why that's failed. Alright, so we go in and we fix this up. It's got rebuild errors. Don't show, click OK. Now we close that off, and what we're going to do is we're going to remove this one out of here, and we're going to go into the library and we're going to fix that piece. Alright, so if we go to World of Members and we go delete, we're going to remove it. It's good that we get these little errors in our little trial videos to show you how to fix them. Okay, so now I've deleted it. We go to our library manager, we go to World of Members, go to table, there it is in our library, and then go open. And this will open up, and it warns you that if you're working in a team environment, others won't be able to insert it until you get out of it. Or you need to do it when no one's using it if you're working in a team environment. But if you're obviously working solo, then there's nothing for you to worry about. Okay, so we've opened up the model and it's in the back end. Okay, so here's the original model behind. And we go back and have a look at what's happened here. That's the piece that played up. You can see they're dangling. Alright, so let's fix them. So the first one, select that piece, hit my tick. The next plane, edit that feature, select that face, hit my green tick and save. Now that piece is updated. Alright, let's leave it in its 3D format view, Control Save, Control S for save, and then exit out. Let's give it a go now and see what happens. So you're back up into selecting one of these items in the tree. Okay, go to table. There's my table. Make sure the data is selected on the right. Click use. Multiple attached model. 1, 2, 3. Hit my green tick. Now when I insert this from the library, all of its detailed drawings are there behind. I can reuse it over and over and over again, and it parametrically updates every time. Okay, so when I put two tables side by side one another, these are going to overhang one another. Now that wasn't really wise to do that, because we're going to have two separate tables, right? So what we want to do is go back into our driving sketch and move them apart, so they're not on top of one another. So to do that, we can do it this way. What I've done in the past is I find that if you click on the sketch segment and go detach segment on drag, that'll move it away. Detach segment on drag is still on. Okay. Take that away. Take that away. Reattach these two. Delete that dimension, sorry. That one and that one, merge. Let's give this a 200 gap between them. It might not be enough because our base plates might clash, but anyway, we'll see. And that wasn't fully defined. You'll notice with my sketches I like to fully define everything. All right, there's a reason for that. It's because when they come in, you go to attach to something that's not fully defined, it might jump all over the place and create a mess. So there's one table, and you'll notice that when this table came in, it's given it the table filter now, whereas before when we first modeled it, it was a frame. Interesting, isn't it? Alright, looks like we didn't move a vertical line across on our next table, which needs to happen. Detach segment on drag. I think we can actually just uncoincidentally mate that one and bring it over to there. Alright, that one's fully defined. There we go. So there's our table attachment sketches gone. Now let's add in the next table. Beams. Select table. Make sure it's populated on the right. Multiple attached sketch segment. Select 1, 2, and 3 and hit my tick. Now I could have copied the original table as well that's in my project and just did a copy of the whole welded member also, which is quicker than me going through that library process trying to find it, which is what I'm going to do on the next one. Okay, so there's my next table, and now I'm going to do it on the next one. Save. Now I'm going to go copy member. In this case, I'm going to copy. I'm going to go multiple attached model. 1, 2, 3. Alright, so here's our third table. So that one was a lot quicker because then I don't have to go through the library trying to find it. And if you get these noises, you can actually go into your audio settings. If you right mouse click and volume mixer, you can turn off Solidworks so the sounds don't come in. So there's our three tables. It didn't take me long, and in that process I've got two heights that are long, two lengths, and 3 lengths are different as well. So now that I've got all those items in my zone assembly, I can then go over and go consolidate. So I'm just going to refresh my consolidation. Because I don't want that anymore. New. Process the selected items. Now what it's going to do is it's consolidating the table sections in table 1, 2 and 3 and all the plates, and it's going to total the whole lot for the project. Instead of dealing with multi-body components in Solidworks and then having 3 separate lists, this has totaled everything for the project. So if I go down here and have a look, I can grab this plate and if I select a surface on the plate, you'll see I've got a little toolbar here, and then select in consolidation is the C button. And you can see now all my plates, when I expand this out, have been collected for the job. There's a total of 12 of them. That's these guys. If you want to see them more selected, zoom out, select the top one and go select. And that selects all of them, and you can see they're all highlighted now. Now if I was to open up one drawing, that's one drawing for all of the same items. And now that I've consolidated, I can go just simply through the process of clicking the documents within Steel Designer Pro and then go update bill of materials. The bill of materials comes in fully populated. Now when you do set your components, this is an error. Make sure your weight is not in millimeters per kilogram or millimeters per gram, which is a Solidworks setting. Make sure that it's actually set correctly. You can see that in your tree. Every time you go to put that, sorry, not in your tree, every time you go to put an item into your project, you'll see that that's set wrong. So when I did my plates, I didn't set this right. So it means that we're going to have to go back to the library model and fix those up to make sure that that table is correct in that setting. Okay, if I go back to that drawing again and open it up, right mouse click, open drawing, and run the bill of materials again, which you have to because it's not linked to the actual model behind, and now the correct weight has come in. Alright, now because these are parametric, it means that if I was to change any of these things, they're linked to the main dimensions. And if I go 5 meters on that table, which is not practical, but I'm just showing you the parametric behavior, if it all being linked, everything will update, and it did. See the power of parametric behavior within Solidworks, welded members, and now that we've consolidated, it's come up with the list of items that have changed, and now we can consolidate those items back into the consolidation list. Alright, so now we can go in and produce a report, but because you're in trial, the only thing that you can do for your reports is an Excel spreadsheet export, because it's limited to what you can do. So this is collecting all of the component data and bringing it in to the table. And then we can group items as well. So let's just say we expand that out and we go, we've got model type plates. So we've got plates and sections in the job. I want to sort by mark, so the marks come out in order. Got my sections, and now I can go export to Excel, and I can put it in here and go cut list. Use the Explorer. Now I don't have Excel on this computer, but we'll see if we can open it anyway. So Steel Designer Pro tutorials, and I saved it in here. There it is. Yeah, I don't have it installed. But what it'll do is it will group the sections and the plates, and it will sort them by mark. Now our reporting facility does a lot more than what I just did. As I said, when I do click on collect, I can't produce any of these other reports, but you can customize your own reports and produce any kind of format that you want for your reports, because it's bringing the data out of SQL. In a trial, we don't give you SQL, you have text files to store all of your data, and it needs a SQL database in order to be able to produce these reports across the top. Okay, since my masses aren't correct, I'm going to fix up the model in the library so that it is. The trick to do that is to go into our welded members, go to our library manager, go to our welded members, click on table, open the table from the library, click rebuild, close off my window. There's my table from the library, and then through this process we go to the tools and we go change units. In here I've got to set up so that I'm going to end up with metric. I don't want to include drawings in the change, and I don't want to include assembly, so I'm just going to do parts. This is going to change all the units, such as warning me, and this is just going to go through all of those items in my library and update them, which it just did for me. Now if I wanted to check it to make sure that all my masses are correct, if I go insert and I go tables, I go bill of materials, just use whatever the standard one is, hit my tick, add it to the current annotation view, and then on the column, if we go insert column left, custom property, and we go weight, where are we? Weight. You can see that that's all set properly now. Obviously the top plate has obviously got to be heavy, 160 kilos. So we're all good now for our table in our library. So that concludes this tutorial. If you've got any questions around what happened and the process that we've covered, please feel free to contact us at support@CAD Craftsman. We'll be happy to answer any of your questions. Thanks for spending some time learning how to use our application. See you on the next tutorial. Bye now.